Thank you. Oh, thank you, Charlie. Thank you, Shannon. Thank you for having me back. I really enjoyed my time. I think it was March. Was I here? Yeah, I really enjoyed interacting with the group in March, and yeah, glad to be back again. Yeah. So as Charlie said, formic acid seems like it might be useful in the fight against this up-and-coming mite, Tropilaelaps, otherwise known as Tropy or Trope, depending on who you talk to. So just a little bit of a background on myself for those of you that may not have been at the meeting before. I'm the honeybee health researcher at NWPA Products, and I've worked there for about 5 years. We're located in southern Ontario, so about a 5-hour drive north of here. And I've been doing honeybee research in one way or another since 2014. So I started out studying honeybee communication, so things like waggle dancing and all the signaling that they're doing. And then sort of transitioned into, I did a little bit of work on nosema and some work on pesticide influences on honeybee behavior. And then, and that was in California. And then I moved back to Canada in 2021, where I took this position, which is now a very applied position. Oh, I've got a little bit of feedback. Okay, so I'm going to be running a demo station today, showing you how to apply Formic Pro, which is the only formulated version of formic acid that exists on the market, at least in North America. And so the alternative to using a formulated version is to use liquid, but in the US that is not legal. So Formic Pro is about the only option that you currently have for applying formic acid, which means that if we're going to get prepared for the potential incursion of Tropilaelaps here, it's probably better to familiarize everyone with how to actually use it properly. Yeah, so I'm going to be showing you how to actually apply it in the hives, and we can go through tips and tricks on how to do that when we're actually looking at it. We have pamphlets that will more thoroughly explain the nuances of using formic acid, but again, we can go through that at the station. So just to back up a little bit, first of all, who has heard of Tropilaelaps? Who has heard of this mite? Many of you. Who knows what Varroa is? Okay, more of you. So as you're probably aware, we have quite a few different treatments available for the Varroa mite, which everyone has to deal with at some point in their life in one way or another. We have everything ranging from cultural controls, like doing splits or brood breaks, all the way to using synthetic chemicals. And in between there's soft chemicals, what we call soft chemicals, that are usually organic acids. Soft is a little bit of a misnomer. It implies that it's somehow nicer or something. And I don't know that that's always the case. So I think that we need to be really careful when we're using even things like soft chemicals. And formic acid falls into this category of what we call soft chemicals. It's an organic acid. We've known since about the 70s that it works fairly well to control Varroa mites. And so beekeepers have been using it in various forms since the 70s. In the late 90s, in the mid 90s, actually it was, the late 80s, when Varroa first arrived in North America, the founder of the company that I work for, NWPA Products, identified that as a potential for development. So formic acid is a fairly dangerous chemical to handle on its own. So in liquid form, people are typically using like 65 or 85% when they're using liquid. It's quite corrosive. It can be quite hazardous, especially if you breathe in the fumes. You certainly don't want to get any on your skin. So the mission of NWPA Products was to develop a method of application of formic acid that would retain the efficacy against Varroa while minimizing the risk to the beekeeper. So it's gone through several phases of development. Initially, it was kind of like pads soaked in acid, and then they were in sort of a baggie that was called Mite Away 2. And then we moved on. We actually redesigned the whole thing. Now it's a polysaccharide-based gel wrapped in a wicking eco paper. So again, when we get to the hives, we'll have a peek at what that actually looks like, and I can show you how to apply it. Okay, so we've known for a long time that it works against Varroa, and in contrast to a few other things that we've been using to fight Varroa, no known resistance has ever developed in Varroa to formic acid, so this is good. Again, in contrast to some other things where they've seemed really promising and they've worked really well initially, but then Varroa were able to develop resistance. So that means that we lose that tool out of the toolbox. That hasn't happened for formic acid, and that probably goes to its mode of action, which is much more diffuse. It targets many more aspects of the Varroa to kill it than some of the other alternatives. And the more things that you target as a chemical control, the harder it is for an organism to develop resistance. The more targeted, the better it works in the short term, but the less promising it is in the long term. Okay, so we've got formic acid, works well against Varroa, no resistance that we know of. And then recently, this Tropilaelaps mite sort of emerged on the horizon. It has a few key differences between Varroa, or the Tropilaelaps is different from Varroa in a few key ways. Does anybody know what any of those ways might be? Number one, it doesn't live here, so that's a good way.
How they reproduce.
How they reproduce. Yes. So there are a couple things. And to be fair, there's a whole bunch of basic biology of Tropilaelaps that we actually just don't know about. So this is a brand new thing. There's been quite a lot of research on basic biology in Varroa. In even Varroa, there are still many mysteries that remain. Tropilaelaps, far less studied, and primarily because it's mostly been in Southeast Asia, is where it has mostly been up until fairly recently. But it's been on the move out of Southeast Asia for the last few decades anyway, but that's really sped up. So how it reproduces faster. So the turnaround time for Tropilaelaps is faster. Varroa actually has to spend some time after it emerges with the mature pupa. Well, it's a mature adult bee at that point. When it emerges, it has to go on to adult bees and feed for some amount of time in order to actually get the right proteins to be able to produce eggs when it goes back into a cell. So that's thought to be around 7 to 8 days that it needs to spend on adult bees. Tropilaelaps doesn't have that. So they don't spend time on adult bees. And furthermore, it seems like they actually cannot feed on adult bees. So this has consequences. This means that when a mature adult Tropilaelaps emerges, because their life cycle, they breed within the brood cell, the same way that the Varroa does. When they emerge, they essentially have to immediately go back into another cell in order to continue their life cycle, because they need immature bees to be able to feed. Their mouth parts are not strong enough, it seems, to be able to feed on adult bees. So not only do they not require that, they actually can't feed on bees, which means that they get back into a cell and they reproduce faster. Things like how many offspring are produced by a Tropilaelaps versus a Varroa. There are numbers out there, but actually we don't know. We don't even really know basic things like that. Like, what is the difference? Another difference, so Varroa tend to prefer a certain population within the hive. Does anybody know who that is? Who do Varroa like to hang out on? Drones, yeah. So they like to reproduce in drone brood cells, and they like to hang out on drone adults. And that probably goes to how long the brood cells are capped. That gives them more opportunity to produce more offspring. So the drone development time is 3 days longer than worker development time. And then drones tend to be very gregarious. They're moving around from colony to colony, which helps with their dispersal. So in their adult phase, they tend to like to be on drones so that they can go and make it into other colonies. So this benefits Varroa. Tropilaelaps, though, doesn't appear to have a preference. We don't know for sure, again, but I have just come back from some field research to this effect, and I'll get into that in a moment. And it doesn't look from the research that we've done and other people have done that they actually have a preference. That may go to the fact that they don't seem to be able to feed on adult bees. So being in a cell for longer, if it's capped for longer, as the pupa develops into an adult bee, they just may not be able to feed on those adult bees. So being in a drone cell might not be to their benefit, but we don't know. We don't know. That's a working hypothesis. Okay, so we've got a few key differences, and what this the total outcome of all of these differences is that the classical ways that we have been using to treat Varroa mites, which are not that distantly related to Tropilaelaps mites, most of the chemicals that we use to treat Varroa mites don't work on Tropilaelaps because they don't spend enough time on adult bees. So a lot of the contact chemicals that we've been using that rely on contact with the actual mites, so they have to walk across a strip or they touch a crystal or something like that, these things don't work for Tropilaelaps mites, at least when there's brood in the colony, because they're essentially all in the brood all the time. So you have to have something that is able to penetrate under sealed brood cappings. And fortunately for us, there's one chemical that we know of that does that, and that's formic acid. So we at NOD have recognized that this is an up-and-coming problem, and I've been really pushing, and NOD has been really pushing for us to focus. We're not a very big company. We have about 40 employees total, so we're not a very big company. We don't have tons and tons of money. We're not big pharma by any means, but I've been pushing to focus our research on Tropilaelaps so that we can really understand how to use our product if it makes it here, and it is for sure moving its way into Europe. So the Europeans will certainly need to know how to use it. So currently, the border of the Tropilaelaps incursion from Southeast Asia, where it started, is around Ukraine, Georgia, Belarus, those regions in there. And it's moving. People speculate that within the next year or two, it'll probably make it as far as Italy. Nothing is really stopping it from moving around. As you guys all know, it's very difficult to keep things like this under wraps with bees because bees move around by themselves. So even if you're not transporting bees, bees are flying, they're moving around. So then they're taking the mites with them. So in preparation for this, I've been lucky enough to be involved in two major research projects with essentially the two main research groups working on Tropilaelaps on the planet right now. So I've been very lucky. I spoke to you guys a bit about my trip to Thailand in October. So we ran our first full field trial on formic acid there in Thailand in October. So that was in Chiang Mai, that's in northern Thailand. And as a result of that, we saw that even at lower doses, so we try to, and probably some of you know that Formic Pro comes in a 2-strip dose, that's a full dose. So even at one strip applied to these hives, we had 100% mortality in sealed brood. So it works very well. It turns out that actually killing Tropilaelaps is quite easy. The problem comes back to how fast they reproduce. So whereas when we're treating for Varroa, we might only have to treat twice a year, probably in this region twice or maybe 3 times a year to get good control. That may not be the case for Tropilaelaps. But so we did this field trial in Thailand in October. We saw 100% mortality in all the treatment groups of Tropilaelaps under the sealed brood. So we basically uncapped brood cells to check if they had died. That was 4 days after application. And all the hives that we looked at that didn't get treatment, 100% of those mites were alive. And in the treatment groups, 100% were dead. So you don't get a more clear outcome than that as a scientist. That's pretty exciting. So the next question, well, there are a couple questions that emerged from that. I don't know if any of you know about Thai beekeeping, but it doesn't look like North American beekeeping. So the climate is different. It's every day that we were there, it was around 33 degrees Celsius, so that's around 90 degrees Fahrenheit. You'd get up in the morning, it would be 30 degrees Celsius. By the afternoon, it would be 33 degrees Celsius. It would rain, and then repeat every single day would be exactly like that. And that was in their dearth season. So October is just going into their, I don't remember if it's just going into or coming out of their rainy season. I think it's just going into the dry season. Nonetheless, quite different from here climatically. The other thing is their equipment looks different. They don't super. So they're harvesting honey, but they're harvesting honey out of brood chambers. In addition to that, although their hives are roughly Langstroth size, they're a special kind of Thai style of hive. They have permanently reduced entrances, so they just have very small windows, and this is to prevent robbing mostly from a lot of the hornet species that are native to Southeast Asia. So to keep those colonies protected, they also tend to keep very small populations. So they're splitting. So if their bees are getting larger than essentially one brood box, they're splitting. They're not supering, they're harvesting honey. It does look quite different from here. So when I went there, because one of the key constraints with using formic acid is ventilation, we had to modify a bunch of Thai hives so that they looked more like Langstroth hives. So we ended up doing that, but then you end up with something where you can answer a scientific question, but you're not really answering an applied beekeeping question, because nobody in Thailand would keep bees that way, and nobody in North America would keep bees that way. So that was questions that emerged from our Thai study. We had good efficacy, but how realistic is this when we actually get down to nuts and bolts? And then on top of that, in Thailand, they've been living with Tropilaelaps for a couple decades already. So and actually probably even longer than that. The beekeepers are used to dealing with it, and that's one of the reasons why they keep smaller colonies, because the more you split, the more brood breaks you have, the more control you get, because they have to have brood in the hive to be able to live. So you're doing a lot of cultural controls. The beekeepers have adapted to it, and very likely the bees have also adapted to this pest, the way that we've seen shifts in how bees handle Varroa populations since the incursions in the 80s in North America. So we wanted to go to a region, so that research was done with Auburn University. So I worked with the Jeff Williams group there. So that was the one group. And then, so we decided that we wanted to follow that up by looking at a more similar beekeeping culture to North America, and also a situation where the bees were naive, where this was a fairly new pest for them to deal with. Because we know in biology that anytime you have a naive host, that host, and host being the bees in this case, that host might respond differently to the parasite at the beginning. And that would be what would be important to learn how to control it at that stage for an incursion into North America. So how do we get a jump on this right at the beginning? Oh, hey, buddy. How do we get a jump on this right at the beginning? How do we deal with a naive bee situation, in addition to having, again, culturally similar beekeeping practices? So I was able to set up, I mentioned, not as a small company. We don't have tons and tons of research dollars to be doing this. So we were able to actually partner with BASF, who gave us a bunch of money because they thought that this was an important question to answer as well. So there are formic acid suppliers. That's why they were interested in doing this as well. So they've actually funded this research. So I was able to partner with Maggie Gill and the group that she's working with, and they work primarily, so Maggie Gill is based in the UK. She runs Phyra Science. It's a non-profit, and she's also one of the premier Tropilaelaps researchers in the world. Was able to partner with them. They have a field site in Georgia, and this is not Georgia the state, this is Georgia the country. Former Soviet Republic, now its own independent country, but it's bordered on the north by Russia and on the south by Turkey, and then we've got Azerbaijan and Armenia. So in that region there. They first confirmed the presence of Tropilaelaps in 2023 or 4, I don't remember, but it was very recently. It was one of those 2 years. I'm sorry, I'm a little bit tired. I literally got back from there on Monday, so I'm still trying to adjust. I'm a little sleep deprived. Yes, so we were able to partner with them, and so I went in April, and we ran a 2-part experiment. So we had questions on how Tropilaelaps would respond in more Western beekeeping culture. And then we wanted to know long-term how often we'd have to do treatments. So I ran part of an experiment in April, where we manipulated a bunch of different doses, saw similar treatment effects to what we saw in Thailand, only the Georgian beekeeping practices are much more similar to here. They run date hives, they don't run Langstroth. And then I just got back from the second part of this, where some of the groups got retreated, so a month and a half after the first treatment. And we're still running numbers on that, but it looks promising so far. And at the end of this, what we're hoping to have is essentially directions for how to actually use Formic Pro. And Charlie's telling me I need to wrap it up, so we can chat more at the station.
Yeah, thank you so much.
How many of you have used Formic Pro before?
couple. How many of you are interested in potentially trying it out? Okay.
I use oxalic acid, and I've used it as I have a gun, and I'd like to start altering back and forth between the two.
Yeah, it's a nice treatment regime. Does anybody have any questions before I start? Okay, well, so I've got an open pack of Formic Pro here. We'll have a look at that in a second. But before we get to our hive, before we open it up, before anything, we're going to think about what we actually need to do. Yeah, it does. It smells a little bit like vinegar. It's a closely related molecule to vinegar, acetic acid. So, number one, we want to make sure that when we're using formic acid is a stressful treatment for the bees, as is any treatment for varroa mites. Oh, hey, harvestman. So, formic acid is a stressful treatment. All varroa treatments are stressful treatments. We want to make sure that our bees are strong before we use it. This is especially important for formic acid because it's a vapor. Other treatments that are contact-based, things like amitraz or even oxalic acid, that relies on the bees interacting with the strips, and so they don't actually get treated unless they interact with whatever the chemical is. But in the case of formic acid, the bees and the mites don't have a choice. It's a vapor, it evaporates out of the strips, and it kind of like moves around the hive and gets everywhere. So you want to make sure, probably more so than most other treatments, that your bees are strong, that they can handle this treatment before. So by strong, I mean if you have run a Langstroth setup, you've got deep Langstroth frames, you should have full-sized equipment first and foremost, so that means 8 or 10 frames. You can use mediums or you can use deeps, that's fine. Different configurations. If you're using mediums, you need to have 2 mediums though, a minimum of that. And you need to have the equivalent of about 6 deep Langstroth frames worth of adult bees. So that's what I would consider to be a hive that is strong enough, or a colony that is strong enough to handle formic acid well, to deal with it well.
Is there any guidance on like the 4-frame like brood factories? Like if you're using like 3-4 frames, or how would you handle that?
Not currently. So okay. I'm actually working on a project in August of this year where I'm going to be running a full field trial on some configurations like that, nukes and things like that. Because that's a question we get a lot. But all of our testing to date has been done in like 8 to 10 frame Langstroth, and in Europe we were using dated hives. It's like very similar. So size, we've got the strength of the colony, but strength also in terms of stress. So you certainly don't want to be treating with anything like the moment that they come off the truck from pollination in California. You don't want to do that. Certainly if you've just split them, or if you've just hived a brand new nuke, you want to give them a chance to acclimate. You want to give them a chance to settle in. So you don't want to be adding stresses to stresses. You want to give yourself the best chance of success. Now there might be scenarios where your mites are completely out of control, where you don't have a choice. But the choice there would be lose them to mites immediately, or set them back with formic acid. In that case, it's a different story. But under ideal circumstances, you want to make sure that they're not stressed. You want to make sure that they're strong enough. You're using full-sized equipment. Your equipment configuration is also really important. So in particular, the entrance for your hive is really important. Does anybody know why?
Ventilation.
Ventilation, right. And which entrance is the most important?
Bottom.
Bottom. Why?
That's where they expel the air.
Sure, it is.
Heavy vapor.
That's right. So formic acid is heavier than air. So it's going to fall, it's going to sort of billow out of the strips, and then it's going to fall sort of cascading, and the bees are going to flush it out the front entrance. So we want to make sure that if we're using a Langstroth box like this, that the front entrance is fully open. Now, if you have permanently reduced entrances, you can do things like shim it up so that you've got essentially the equivalent of a fully open Langstroth box there.
What's your experience with like the Man Lake moving robbing screen that gives a full screen front?
Okay, so we don't want to have any kind of thing that where if there is bee mortality, because there is sometimes bee mortality with formic acid, you don't want to get into a scenario where bees are dying and then stuck there. Because
Okay.
then they're going to trap all the vapors inside, and then you're going to nuke your colony. So you don't
Okay.
want that. Yeah, so you want to make sure that screens are off, the entrance is fully open. It doesn't matter if you have upper entrances, that doesn't matter. So you can have upper entrances, that's fine. Screen bottom boards though. So if you've got a screen bottom board, you need to make sure that the tray is inserted. So we want ventilation, we want the bees to be able to flush out the vapors, but we also want treatment effects. That means that we don't want all the vapors to just fall right out the bottom because you've got a screen bottom board and you've got it open. So especially during the treatment period, which is 14 days, make sure that that screen bottom board is in there. That'll also help you monitor to see if it's actually working, so you can actually see mites dropping on the screen bottom board if you're using it that way. Okay, so we've got a strong colony that's not under stress. We've got adequate ventilation. One of the other key factors for using formic acid is what the weather is doing outside, and in particular the temperature. So the really important factor for temperature, what is the daytime high on the day of application? So it doesn't matter what the low is, it doesn't matter what the average temperature is, it matters what the high point of that day is. So it needs to be between 50 degrees and 85 degrees. I think I've got a pamphlet here that says 80 degrees. So whoever wrote that pamphlet was being extra cautious, but that was our distributor, not us. I will say up to 85 is fine.
That's only the day of application.
That's only the day of application. Okay. So I think on some of our literature it mentions the first 3 days,
yeah,
but it's
it does.
really only the day of application.
Because that was like always a tough thing, like fall treatment, like goldenrod flow coming on to like get 3 days in that range.
Yeah, and fair, but no, our
Okay.
data shows that it's really just the day.
Okay.
You know, a large component of the formic acid that's going to evaporate evaporates on the first day. There's still evaporation out that's still having a therapeutic benefit later on, but like the danger zone for bees specifically is really the first day.
Okay, that's good to know.
So yeah, as long as you can get something below 85 for the first day, you know, then you're fine. Okay, so you've met all those conditions. You've got a queen right, happy, full-sized colony. What are you gonna do? You're gonna open it up. So in a single or a double, so if you're running mediums, you would put the treatment on the top of the second medium, but in a single brood chamber, you're gonna put it on top of the brood chamber. If you're running double brood chambers, deep Langstroth boxes, you're gonna put it in the same place. So on the top of the bottom box. So formic acid, as I mentioned in my little talk before, the big benefit of using formic acid is that it gets into sealed brood cells, right? So the actual treatment is much shorter with formic acid than it is for other things. That's because it can essentially kill all of the brood state or of the stages of development of the mite at the same time. So you want to get the strips as close to the brood as you possibly can. So in a single hive, that's going to be set on top of the top of the box. In a double hive, because the brood nest tends to be kind of like a sphere in the middle there, you're essentially optimizing that. So you're getting the strips as close to, actually right in the center of the brood nest there in a double hive. So the formic acid is still going to billow up a little bit and then fall down, but you're doing the maximum benefit there. So you've got your hive, you're going to open it up. I like to scrape the top bars to make sure that you're applying it evenly and levelly. And then you're gonna, this is open, so you can probably already start to smell it. You're gonna wear protective equipment such as what I'm wearing, which is just your normal, probably beekeeping equipment, in addition to some kind of impermeable glove. Nitrile is fine. These are just dish gloves. Latex is fine also. You don't want to apply with your leather beekeeping gloves because the formic acid will soak into that, and that's gonna be bad news for you later on. So formic acid is quite corrosive. And certainly if you like touch your eye or something, bad news. So you want to make sure that you're wearing your impermeable beekeeping gloves, unless you're applying this in like 1,000 hives. If you're doing like 10 or so hives or fewer than that, you don't need to bother with a respirator. Just make sure that you're opening the packages away from your face. Downwind is a good idea. You're going to open it, looks like this. You want to leave that paper on because it's actually functions as a wick as well. These are normally attached together, but because I already did this one time, they're no longer attached together. You just have to pull it. They're quite, these are older strips, so they look damp. That's fine. It works just fine. Pull it apart. You got your box.
Then you're going to lay them perpendicular to the frames, and you're going to sort of optimize or maximize the distribution. So kind of like a trombone, all the way to the edge, all the way to the edge, 1/3 in, 1/3 in.
And you'll do both of them.
And so I always recommend here to do the 2-strip option. So there are 2 treatment options in North America. Close that up. 2 treatment options in North America. You can do 2 strips at one time for 14 days, or you can do 1 strip, which you would place right in the center, and then 10 days later you're going to swap it out with another new strip. Which do I recommend? The 2 strips is going to do a better job and make sure that you're really getting into the brood cells and doing the maximum benefit.
Can you still do that if you're running 8-frame equipment with
Yes.
the 2 strips?
Yeah.
Okay.
So we've
I think
tested
it was
it to 8 frames.
recommended that it was initially like the 7-day method with the.
Yeah. So I will tell you that I ran a study on this last year actually, where I looked at the 1+1 method versus the 2 method. And I looked at it at 2 different times. So I looked at it in spring, so it was like mid-May, and then there was another time point like at the end of June. In mid-May, the 1+1 treatment and the 2-strip treatment behaved the same. So the efficacy was the same. I attribute that to the weather. The colonies are smaller-ish. They have a decent amount of brood, but it's not the maximum amount of brood. And most crucially, probably, the mite level is very, very low in spring. So efficacy was the same between those 2 options then. But when I did the treatment in midsummer, in June, the 2-strip treatment still performed fantastically. The 1-strip treatment did not work as well. And I think that that's because it's hotter, the bees are fanning more, the colonies are bigger, they're more robust, there's a ton of brood in there. So I always recommend to use the 2 strips.
Do you recommend adding the super to let them get away from the vapor?
So that's something, especially if it's hotter, we always recommend to add a honey super if you don't already have one in place. So you are allowed to use Formic Pro when you are actually making honey, so that is fine.
It doesn't have that scent in it.
No, so
Really?
formic acid doesn't stick, the configuration of the molecule, it doesn't stick to the wax. It will get into the honey a little bit, but then it tends to evaporate out, and there's already formic acid in honey. So yeah,
And
so
being a denser air probably helps not rise to the
Drops it
honey
down.
as well.
yeah, it's so we've done a lot of testing. I have quite a lot of data on like sampling honey when we've applied it, like at various time points afterwards, and it never elevates the level of acidity of the honey beyond what occurs in some naturally occurring honeys already. Where was I? Now I've forgotten. So yes, we've got our treatments on. Basically, close it up. I always recommend the 2-strip treatment here, especially so you've met all the other conditions. You're safe to go for a 2-strip treatment. That's going to be the biggest bang for the buck. You really want to get everybody all at one time. So everything that's in the brood, everything that's out on the adult bees. One thing I didn't actually mention in my talk was, especially when I was doing research in Georgia, so there's co-infestation between Varroa and Tropilaelaps. I mentioned Tropilaelaps is easy to kill, but the reproduction rate means that maybe we'll have to treat more often. But the real clincher here is that Varroa remains harder to kill. So we have to apply a big enough dose that we can actually target both of those mites at the same time. But then with the understanding that we might have to increase the frequency of the treatment. So that's where I am right now, is actually trying to optimize that, because is 2 strips going to be too much if we have to do it like every month? Like that seems like a lot. Because certainly there are other implications to using any kind of treatment. It's going to set your brood back. It could impact your honey production, things like that. So you want to minimize the number of treatments that you're doing.
I do have a question.
Sure.
What is the closest that you could do them together?
1 month is what we're
1
recommending.
month's what
So
you're recommending? Huh?
yeah, so if you apply on June 1st, for instance, you would not want to reapply until July 1st.
Okay, even that's close.
It's quite close.
Yeah.
Yeah, that would be, I would think that would be like an emergency situation.
Yeah, I just wondered what the specs were on it.
Yeah. And certainly you want to be monitoring. So I know there's a station down there that's monitoring for mites. So you definitely, to know if your treatment's working or not, you need to know what your mite levels were before and what they were after. So knowing what they are after doesn't really tell you a lot, because if the levels were very high when you treated, no treatment will do 100% kill. So even the strongest dose of formic acid is not going to kill 100% of the mites. So you could still conceivably, especially, so here's something that I see fairly often in my own research too. So I'll apply a treatment maybe at the beginning of September. In September, brood production is winding down, the amount of brood is reducing, the amount of Varroa in brood is going to be lower because there just isn't very much brood. So all the Varroa has to essentially move out onto the adult bees. So you could very conceivably, and I see this all the time, do a treatment where you do a mite wash before the treatment and then after the treatment, and you actually have the same amount of mites. And that's just because they're moving out of the brood. So you might have killed a whole bunch of them. But in a mite wash, all you're sampling is the adult bees with the Varroa on them. So you could conceivably see the same levels. You'll know, the only way that you would know that the treatment was actually working is if you do what I do, which is have an untreated control group running beside that. And then you can see in those colonies, you know, the mite levels spike up like 10 times in the same amount of time. So at the end of the day, knowing what your mite load was before and after treatment can be somewhat informative, but also still doesn't really give you the full picture, especially if you're using mite washes.
I have a question for
Yep.
you.
Question here.
Go ahead,
I'm not
Charlie.
sure who was first.
I have some NWPA Pro that I bought last year. It has an expiration date of July of 26. Do I have any grace period in using those leftover sheets?
Officially, no. Officially,
Actually, no.
Officially, the expiration date is the expiration date, and you shouldn't use it after that. But I will say, in Canada, we were granted a 2.5-year expiry, as opposed to a 2-year, which is what it is everywhere else. And just for the ease of translating information to people, we've just made it 2 years everywhere. But I will say that it has been demonstrated to be safe in Canada for 2.5 years, but officially in the U.S. for legally.
Here, we may listen on my phone.
Yeah. Yeah.
Hey, thank you.
Yeah, no worries.
My question for you, made my treatments, I'm ready to get, how do I dispose of
Good question.
Formic Pro?
So Formic Pro is completely compostable, and it's made of totally biodegradable materials. So first of all, you don't have to worry about getting back into your hives and taking it out right away. I routinely treat in September and don't do anything until like April when I go back in for my spring inspections. That is absolutely fine. Because formic acid is already in the hive environment, you're not really subjecting them to low levels of chemicals that they're not already being subjected to. So the development of resistance isn't an issue the way that it is with some other things which aren't native to the hive environment. How do you actually dispose of it? What I do is I rip the strips out, I throw them on the ground, and then I mow them. But you can also compost them.
Good
Kills
enough.
the grass too.
It does, although if you wait for 6 months, it really doesn't.
Immediately.
Yes, if you pulled them out after the 14-day treatment, there could still be conceivably some active. I would certainly use gloves. Like if you're going to pull them out 14 days, there could be enough acid still left in there that it might do something to the tips of your fingers. So it's always a good idea to use gloves when you pull them out.
Okay.
Would you try and treat before you had like a major honey flow to avoid that? Because that's what I ran into. Like whenever you said about the 3-day temperatures in a row, like it pushed it back later than what I would have liked to have.
Yeah.
But knowing the 1 day makes a difference. So I treated and they had the brood break from the treatment, and then the goldenrod came on, and I had a lot of issue with getting honey bound.
Yeah.
So try and do that before the
You
major
really-
nectar flow.
You need to understand your year. I mean, you understand your year and the ebbs and flows in the year. You want to optimize Formic Pro so that they're strong enough, but it's early enough in the season that it's not going to impact, because you're going to need, a few weeks to bounce back from the treatment effects there. So yeah, you want to, if you're able to, with the way that your season works specifically where you are, optimize that. And both ends of the, so we do a spring and a fall treatment, same deal. So you want to make sure that you get the last of your honey crop off, for instance, before you're treating, and it's probably easier and
the
better.
1 day makes a big difference of achieving that versus 3.
Yeah.
What's your recommendations for altering with Formic Pro and silic acid?
I don't personally, I actually just use Formic, but I know a number of other people in my company. So I work with a bunch of other people who are either former or current commercial beekeepers, and they're often doing cleanup treatments with oxalic at the end of the year. So yeah, I think that's a good complementary regime, is to use them on and off. And they have different strengths and weaknesses, because Formic has all these temperature constraints. Oxalic doesn't really have those temperature constraints. But oxalic can't really be used when there's a bunch of brood in there, whereas Formic can. So yeah.
So Formic would be more of like your winter and your fall, versus this would be more of summer.
Yeah, I would
Is that what you're
say.
thinking?
I mean, so again, I like to do Formic in the spring, before, like, to make sure that everything is clean before you really get rolling. Then if you wanted to do like an extended release oxalic, certainly you could do that over the summer. They really need to be broodless, like brood reduced, for that to be very effective. You can do multiple applications, but even doing up to 5 applications, not really that effective when there's a bunch of brood in there.
Okay.
So oxalic certainly works better, earlier on in the spring or later on in the fall. Yeah.
Okay.
Yeah.
What are you thinking?